So the title of my talk today is the underestimated power of KeyPaths. So let's begin by reminding ourselves what KeyPaths are. So KeyPaths, they were introduced with Suite 4, and they basically offer us a way to defer the call to the getter or the setter of a property. So what does it look like in code? So KeyPath is a generic type. It has two generic parameters. The first one is the type on which you will invoke the KeyPath. The second one is the type of the property you want to get or set. And to get a literal KeyPath, you use this syntax where it's backslash, name of the type, dot, name of the property, or in places where the type can be inferred, just backslash, dot, name of the properties. So how do you use it? Let's take a string. We're going to invoke the KeyPath on it with this syntax, which is very close to a dictionary, and we get the value of the count, which is 15. And basically, you can see that they perform the same job than the getter or setter closure, just with much less curly braces and $zeros hanging around your code. So let's see how they can be leveraged with an example. So we're all familiar with this kind of Swift code. So functional programming, you take a closure, and let's see if we can make it work with a KeyPath. So for this, we're going to introduce an operator. So it's going to be a very short operator, just the caret character. It's a prefix operator. And let's look at the signature. We're going to take a KeyPath that's going to be invoked on a type to get a property, and we'll return a function that takes a type and returns the property. So we are going to map from KeyPath to getter functions. How do we do this? We return a function. This function takes an object, and we invoke the KeyPath on the object. Nothing fancy here, but with this, we're now able to turn this code into this code, and with just one extra character added, the operator, every single function in the standard library that expects a getter closure can now work with KeyPath. So that's pretty nice. But as we know, in the standard library, it's not always this simple. For instance, you have functions like this, like sorted, where you expect a closure that will perform a comparison, meaning return a Boolean. And you'd like it to work with a KeyPath because basically, as you can see, most of the time, we're going to compare objects on the same field, on the same property, because it just makes sense in the business logic. So how can we do this? We're just going to write a new helper, so we're going to call it there. You'll understand why in a minute. So it's going to take a couple of things as parameter. It's going to take first a KeyPath, so over a type to get a property, and it's going to get a comparator, so it's a function that takes two instances of the property type, and it returns a Boolean, so standard comparison function. And to make the code less easy to use, we're going to give it a default value, which is the less than operator. And we're going to return a function that takes two instances of a type and return a Boolean, so a comparison function for the type. So we're going to return a function, like I said, it takes two objects from a type. Inside, we just invoke the KeyPath over both objects, and we call the comparator. And with this, we are now able to turn code like this into this kind of code, which reads like very good English, people sorted by their last name, and you've got just enough punctuation to make it like some legit computer syntax. And if you want to go for even fancier stuff, you can see that you can provide a custom comparison operator, and the syntax is still very nice. It's people sorted by their last name compared with strictly greater than. So this is a lightning talk, so this is the end of the talk. I've only been able to show you the tip of the iceberg, but I want you to get away from this talk that KeyPaths are great, they are underused, but you should use them. You can have many other possibilities. For instance, with KeyPaths you can build type-safe predicates that perform the same job than NS predicate, but with a type-safe approach. So it looks like this syntax. If you're interested in seeing more, I've left you a link to a GitHub. So it's a repo I have on GitHub where you can see how you can implement predicate system and lots of other cool stuff with KeyPaths. So if you enjoyed this talk, please go check it out.